Today in class, we completed Unit 7, Lesson 3, Children's Barnyard Revisited, where we explored the key features of the product of two linear functions. In the Ready section of tonight's homework, we will be using the distributive property and exponent rules to simplify polynomials and write them in standard form. A polynomial is an expression consisting of multiple terms. A monomial would contain one term, a binomial would contain two terms, and a trinomial would contain three terms. In the first example, we're going to distribute the 2x to each of the terms in the linear expression 7 minus x. 2x times 7 gives us 14x, and 2x times negative x gives us negative 2x squared. We need to write this in standard form, and the standard form of a polynomial with one variable is written with the highest degree or exponent first. In the second example, we're going to first distribute the x outside the first linear expression to each term within the parentheses. So the x times the 5x would give us 5x squared, and the x times negative 10 would give us negative 10x. Next, we're going to distribute the negative 3 to each of the terms inside the parentheses. Negative 3 times x is negative 3x, and negative 3 times 11 is negative 33. Next, we will simplify our like terms. We have two x terms. We will combine them through addition. Negative 10x plus negative 3x is negative 13x. Because we have no other terms that are like the 5x squared and the constant negative 33, we simply bring those down. This polynomial is already written in standard form because the variable with the highest degree is already listed first. Here's another example. Again, we're going to distribute that x to each term within the parentheses. X times x squared would give me x cubed. Remember, x squared in expanded form is x times x. So essentially, we are multiplying three x's together to give us x cubed. And x times negative 4 is negative 4x. Then we will distribute the x to each of the terms inside the second set of parentheses. X times 12 is 12x. X times negative x is negative x squared. We will combine our like terms. Negative 4x plus 12x, which is positive 8x. There are no other terms like x cubed or x squared, so we simply bring those down. This is not written in standard form, so we need to rearrange our terms from the highest degree to the lowest, or the highest exponent to the lowest. Remember the term 8x. If there is no exponent written, it's understood to be 1. In the set section, we are finding the product of two linear binomials. We're going to use the same strategy, which is the distributive property. We will take the first term in the first set of parentheses and distribute it to each of the terms in the second set of parentheses. X times 5x is 5x squared, and x times 2 is 2x. Next, we'll take the second term in the first set of parentheses and distribute it to each of the terms in the second set of parentheses. Negative 6 times 5x is negative 30x. Negative 6 times 2 is negative 12. We will combine our like terms. Positive 2 minus 30x is negative 28x, We have no other terms with an x squared, and we have no other constant terms other than the -12, so we simply bring those down, and this is already written in standard form. In the Go section, we will be evaluating quadratic functions for a given value of x. Looking at the graph, we see that we are looking at an object in flight, and we are given the time in seconds and the height in feet. First, we're being asked to determine the function of 0. In other words, when the time is 0, what is the height of the object? We can see on the graph that when x is 0, y is also 0. So when 0 time has passed, the object is 0 feet from the ground. When we look at the x value equaling 20, or at 20 seconds, what is the height of the object? We can see from the graph that it is 400 feet off the ground. We can also see that this is the maximum point of this quadratic function. And if we were to continue on with this, we could see that it crosses our x-axis again at 40 seconds, which tells us that at 40 seconds, the object would be back down on the ground. So it would take 40 seconds for the object to be launched, hit its maximum height, and come back to the ground. In the second part of the Go homework, we are going to be evaluating functions for a given x value. We're being asked to find the function of -2. So when the x value is -2, what is the function of that, or what is the y value? All we need to do is substitute all of our x's with a -2 and simplify. We're going to use order of operations, so we're going to square that -2 to get +4. And in the second term, we are multiplying the 7 by the -2 to get -14. Next, we will multiply this first term, the -5 times the 4, to get -20. And now we have 3 terms that we will simply add together to get -35. So the function of -2 is -35.